This is a podcast of Scripps Institution of Oceanography at UC San Diego. To learn more about how you can support Scripps, visit us online at scripps.ucsd.edu. In February, Scripps researchers Tim Barnett and David Pierce dropped a bombshell when they released an analysis showing that Lake Mead, a key water source for millions of people in the Southwest, could run dry within 15 years without changes in its use. The news drew public attention to a far-reaching situation in which the Colorado River supply at Lake Mead is only one problem spot. Climate researchers at Scripps are also tracking growing threats to the water that Southern California gets from the Sierra Nevada and to the West's groundwater reserves.
California is facing changes in when its water supplies will be available and how much water will be available.
The crisis will be here within 20 years. There's no way that we can change the carbon balance of the atmosphere in that period of time, so it has to be a program of adaptation, first of all. Second of all, we already have a resident population here that uses all of the water out of the Colorado River. Basically, it's fully subscribed. And we're proposing to add more. I heard somebody say they were going to double the population of the state of California by 2050. I don't know what they're going to drink, but it's not going to be water.
The water will be showing up more in winter than in summer. And along with that, it's a little bit less certain, but we also expect that with warmer temperatures, there'll be more tendency for evaporation. And so there'll just be generally less water available, both in the Colorado River Basin, where we get a lot of our water, and in California's water supplies from the Sierra Nevada and the like. Tim's work on the Colorado River recently has shown that severe impacts, in particular, as Tim would put it, essentially the drying out of Lake Powell and Lake Mead, the two largest reservoirs on the Colorado River, may be only 20 years away, and certainly not much more than 30 or 40 years away.
You know, we're in a situation now where we're right up against the edge. There are some things that can be done that will give us some time. Certainly recycling water would be one thing, building more dams, conservation. There's a whole litany of things. You know, this problem has been on the table for 20 years or more, and there's no shortage of ideas as to what to do about it. There's just been no will to do anything about it. Now there will be.
Western states have turned to Scripps and other research centers to understand what to expect from global warming and how best to respond. Researchers say that if there is any bright side to the water crisis, it's in the technological advances over the past 20 years that have allowed scientists to better see unfolding climate change-related threats and give mitigation and adaptation measures a head start.
The state hydrologist, Maury Roos, 20 years ago, I guess now, recognized that something was going on in California. But it was work here at Scripps, largely ever since then, that has documented just how real those changes are and how widespread they are, and has linked changes in stream flow timing and snow melt to changes in when plants green up and the like. And so really a lot of the evidence that this is real for us in California and across the West came out of research that was done here at Scripps. Scripps has become essentially the go-to institution for a lot of state agencies in terms of climate change. And our role has very much become one of being the institution that wades through the large number of projections that are available of sea level rise, of warming trends, of water resource impacts, that sort of thing, and helping the state agencies to sort through those to focus on the ones that are most likely or most pressing.
For Dettinger, who routinely travels to the Sierra Nevada to track hydrological trends, innovation has come in the form of rugged miniaturized measurement devices. Meanwhile, Barnett, a pioneer in long-range climate forecasting, marvels at how powerful and accurate computer models have become.
When I first looked at them a couple of decades ago, they didn't even have the wind blowing the right way over the Pacific Ocean. Didn't obviously spend much time on them. but they've gotten better and better with each iteration. I'd say we're sort of in the 4th or 5th generation of climate models right now, and there are a lot of things that they really do well. They're still not perfect by any means. Precipitation is very hard for them to do, and a few other variables, but by and large, they're our best shot for looking at the future, and they all seem to be telling us pretty much the same story.
This little instrument here is one that we can literally just put in a river to measure the depth of the river every half hour for a year, and then come back a year later to get all the data. And 20 years ago, the instruments required to do this would have roughly been about the size, it would have fit in a space about the size of a picnic table or something like that. This little guy is even smaller, and this measures temperatures. It'll measure air temperatures or water temperatures or whatever you put it inside of. And again, you can put this out in a stream or even hang it in a tree and measure measurements every half hour for up to 3 years before you have to go and get it. You know, those kind of technological advances really are what are going to make it possible for us to keep up with and keep track of climate change and its impacts as they occur without having to begin all over again with a whole new set of monitoring networks.
This has been a presentation of Scripps Institution of Oceanography at UC San Diego.